Welcome, everybody. It's really nice to see you all. My name is Monty Paulson. I lead the Passive House team at RDH Building Science. It is nice to be back here. Wednesdays has become a high point of my week. It's my pleasure to honor and welcome each and every one of you to this Passive House Happy Hour hosted by Pacifist Accelerator. This is an intentionally and inclusive gathering. We welcome people from all Passive House communities, as well as anyone else working to create zero emissions buildings with less embodied carbon. So please turn on cameras. We'd like to see your faces. Turn on your microphones for a minute. We'd like to hear your voice for a toast. Raise a glass or a can or whatever you have on a hot day, and let's toast to Night Flush, the free cooling that keeps on giving.
Very nice. You're here.
Cheers. Hot flush.
Cheers.
All right, so close those other apps you've got open because we have a great show tonight. First up, Zach is going to orient us to the Accelerator's YouTube channel and the happy hour videos there. He also has what I have rumor is a big Accelerator announcement. And we have a presentation about one of the most innovative little houses in Vancouver, the Blindheim Passive House by Ian Robertson. I know you're going to want to see that. Now, I'm sad to report that our co-host, Prudence Ferrer, is taking a well-deserved week off. So I'm going to turn things directly over to Zach here.
All right, great. So I would like to share our YouTube channel with everyone because we get lots of requests for videos of these happy hours. And so if you go to YouTube and find the Passive House Accelerator YouTube channel, which I will provide a link to, you will be presented with these four kind of rows of videos. So the first one are Passive House presentations to the happy hour. So these are just the presentation portion of the happy hour that shows the leading practitioner or expert doing their slideshow presentation. So that's a great resource.
Carve out all of this garbage that myself and Zach say before.
Yeah, exactly. We get rid of this crap. Thank you for that, Monty. And then we also have we have our first Passive House walkthrough here that Michael and his team did of a Brooklyn brownstone retrofit. We'll have many more walkthroughs that populate this row, so you can come and look for those. Same story here. We have the Mitsubishi Passive House component spotlight, and we'll have more coming from other manufacturers. And then if you are a glutton for punishment or you want to look at the Q&A and stuff, you can access full-length Passive House Happy Hour videos here at the bottom. So that's the first announcement. And like I say, I promised I would. I'll do a link to that. The next announcement is that we have just launched our Passive House podcast, which is super exciting. And I am working with Matthew Cutler Welsh and a team of folks at the Accelerator to make this happen. Matthew Cutler Welsh is a New Zealand-based communicator and proselytizer about high-performance building who's been doing this for many years. So he's really the brains behind the operation. And I think he may be here on the call. Matthew, are you here?
Yep.
Great.
I've just
so
joined
Matthew, awesome. Can you say a few words about the podcast, its inspiration, and what we have planned?
Yeah. So thank you, Zach, and also special mention to Sydney behind the scenes for all the work she's done getting this together. It's not an easy thing pulling a podcast together at the best of times, but working with people across different parts of the world and also being in partial lockdown just adds a bit of spice to all that. So yeah, I've been podcasting, talking about just sustainable design for nearly 8 years on and off. And during that process kind of came into contact with Passive House and have started learning more and more about it. So my Homestyle Green podcast has evolved a little bit more. And I remember having a conversation with Elrond Burrell, who's Passive House designer and is actually chair of Passive House Institute New Zealand. A lot of you know Elrond from conferences. I spoke to him 2 or 3 years ago about maybe, hey, we should create a Passive House podcast. And he kind of said, you go ahead and do that. And it's taken this long to get around to it. But I think the Accelerator and the community here has been a real extra motivation to kick it off. So it's exciting to see it up and running now.
Thank you, Matthew. And it's really great to be working with you on it. So the podcast is available on Apple Podcasts, on Spotify, and on a whole bunch of other channels as well. I'm going to share the Apple Podcast URL now, and here it is. But if you go to your favorite channel and look up Passive House Podcast, you'll see the first episode, which is an interview that Matthew did of me and of Michael Ingwe, the founder of Passive House Accelerator. So thank you. Here are the announcements. So one is that Ken Levinson, who is the new executive director of North American Passive House Network, the inaugural executive director, is beginning a lunchtime special every Thursday. He'll be doing an introduction to Passive House, which is actually also eligible for AIA credit. And it will be alternating between 12:30 p.m. Eastern Standard Time, which will be the time tomorrow, and noon Pacific Standard Time, so that it's accessible to different time zones. And you can get more information at the NAPHN website. We also have our favorite kind of associated Passive House gatherings that happen every week. One with Passive House Canada that happens in the morning on Wednesdays, and one by Fine Home Building, another by Dave Cooper and Mark Wiley. So Mark can share information about that, about what's on tap this Friday, but those are the links. I'll share all this stuff in chat in a moment. Also, Architecture 2030 is doing a series of global events, the Carbon Positive Reset, 1.5 degrees Celsius global teach-ins. And the first one is going to be targeted for North and South America audiences, and it's on September 8th. This is a free event. It's pretty exciting, all about zero carbon building, and you can register there at carbonpositive.org. I guess I should say positive carbon building. And finally, the 24th International Passive House Conference is about to happen. It's a virtual conference. It's starting in just a couple of weeks, or I guess it's happening in just a couple of weeks, and the early bird deadline has not passed, so you can still receive a discount on registration at passivehouseconference.org. And I want to thank our founding sponsors for making our work possible and programming like the podcast possible. So Baxtingwe Architects, Mitsubishi Electric, RDH Building Science, Stowe Corp, and Zola Windows. Also, thank you to our stakeholder partner, NYSERDA, and our patron sponsors, Morrison Hershfield and 475 High Performance Building Supply. Thank you. And with that, I'm going to hand it off to Monty.
Sorry, old guy on mute. There should be some kind of special penalty for that. No, I was just thanking you for showing us the video library and noting that we're really inviting everybody to submit short 1, 2, 3 minute videos of a Passive House walkthrough, Passive House tour, something you can shoot on your mobile phone, edit on your laptop. If you need editing help, we're trying to figure out a way to organize some training around that. But we're really encouraging everybody to find ways to make short videos that can be shared by social media, because we're probably going to be in this lockdown situation for quite a while longer, and it's a great way for us to be following along with what's happening in other Passive House places. Now, some of you on the call might be dialing in from a community where there may be a few dozen Passive House people, and you tend to know them all. Vancouver used to be like that. Just a few years ago, every time we had a Passive House social or Passive House event, often organized by Sean here, we'd have the same, 40 or 50 people showing up at those events. And Ian Robertson was almost always there. He was a regular for many, many years in this town. But Ian was always much more than that. Ian has lived in 6 countries on 3 continents. He's done internships in Vienna and Rotterdam. He earned a master's in architecture from the University of South Wales in Sydney, Australia, where they have a real sustainability school. Before moving to Vancouver in 2011, he now works at A.A. Robbins Architects, although the project he's about to show you was designed in part while he was at ABBARCH Architecture, to which he still consults here in Vancouver. His Twitter account describes him as a modest egomaniac, a secular humanist, misanthrope, and an erratic Marxist. I definitely can't top that for a one-sentence introduction. And as you will see in a moment, Ian is a master of embracing new technologies and new ideas as tools to make the design free and simple. And so it is my pleasure to introduce one of the quirkiest and most daring architects I know, Ian Robertson.
So welcome, thank you Monty, by the way. Welcome to the Blindheim Passive House. It's on Blenheim Street, but since everything in Passive House is German, so too must be the name. And the German version of Blenheim is Blindheim. So again, my name is Ian Robertson. I've been in Vancouver since 2011, and this is my first Passive House. So I figured let's toss everything in that I can. Passive House consultant who helped me greatly was Pierre-Andre Santin, and he's online as well, and he can help me later answer some questions that I've forgotten, because it's been a little while since I designed the thing. And okay, so I love this is one of my favorite quotes, and I've got my own version of it. I love rules. I love the creaking noise they make when they get pushed to their limit. It's not the best quote, maybe. But the standard one that I kept hearing when I got into Passive House, although it's been disproved many times kind of since, is that Passive Houses must have small windows. And I took that as a challenge. So the Blindheim Passive House, again, it's in Vancouver, north-south orientation lot, a little bit wider than normal, which helps out a lot, actually. The normal 33-foot lot gets a bit tight. Limited views to the north, but present, so you know, we had to have windows kind of on all sides. So I couldn't do this as much as I would like to. And this is actually a design from A.A. Robbins. So no windows to the street is actually a precedent here. And the client specifically didn't specifically want a passive house per se, but they did want all the superlatives that a passive house does. So when I kind of added all of these things together, it's, you know, each one of these has a little bit of an additional cost over what a bog standard thing might be. So, you know, why not actually just put them together and do it properly? And then the fact that at that time, there was a bit of a bonus for doing a passive house in terms of permitting, that certainly didn't help either. And this has come down in Vancouver, it's become a little bit more normal, but for a while it was like nuts to get a permit in Vancouver. So that was a big motivation. So the project zoning, it's in an RS5 zone, which is one of 33 different residential zones in Vancouver. It's impossible to remember them all, so I try not to. But basically, most of them are RS1, you get a peaky roof with some weird steps on the side. RS5, at least you get a big boxy thing if you want it. But if you want to go as high as you could, you have to do a peaky roof of some kind. Peaky roof in that, though, means less head height on the edges, unless you do a butterfly roof. And then you get the best of all worlds, and that's exactly what I did. Instead of doing just a standard butterfly roof, you can crank it a little bit and make it a bit more interesting. And then this is the initial design studies, and essentially it hasn't changed at all since the sketch on the bottom right. So it just has to have a minimum of 712 pitch. Doesn't say that you can't have more than one of them, and so toss two of them together and you've got a great roof. So the massing diagram, it's basically a block on top of two chunks with a glass in the middle. Pretty dumb, but in this case, you know, dumb is good, simple is good. And I mean, that's what Passive House relies on a lot. So you enter into the basement because I wanted to have the entire house as much as possible above grade and functionally above grade. Because honestly, basements don't really help anybody. But in Vancouver, you're required that about a third of your area is in the basement. To its detriment, but whatever, can't change it, so let's break this rule. Too hard to see this drawing, but so from early concept model to render to reality. You know, pretty legible, pretty simple, follows the same lines. On the south facade, similarly, we've got some pretty big glass. And then henceforth, I'm going to be measuring my glass in Stevens, because, you know, why have small windows? You don't need to have them. This is literally the biggest glass actually we can get on the West Coast without having to go to funky European glass, which costs more. And in this case, we've got 2.1 Stevens by 1.6 Stevens, which I think is a pretty good measure. It's, you know, pretty good sized glass. So, so they have small windows. No, they don't. You can do a butterfly roof to make best use of area. If you raise up the basement as much as possible, it doesn't have to be dark. And if you mean the floor above the basement is really, really skinny, you don't have to drop it down on the ground very much. So built, you know, it was very normal to start out with just gravel, minimal penetrations, big whack of foam underneath. It was supposed to be GPS. We changed it to EPS because it was way cheaper for some reason. Then used a nice commercial grade membrane system, ran all the HRV pipes essentially through the slab. The thing is, this is about the only concrete in the whole project. Once that was poured, although we could have reduced a little bit if we'd coffered the underside. So basements are slow to make and they're carbon intensive. Well, why do they have to be concrete and why do you have to build them on site? These exist. These came out of Alberta. So these are a magnesium oxide skinned SIP panel. So it's basically an advanced frame wall with treated lumber inside. And then you're not relying on a concrete foundation for your waterproofing anyway, honestly. You're relying on your membrane. So use a good membrane with these things. And you get a basement which instead of being R0 is R50 something, you know, with minimal outside insulation than needed instead of having to backfill 12, 14, whatever inches of insulation you might otherwise need. So, you know, yeah, we were really careful about the waterproofing system and everything like that. We've got a good commercial system. So the interesting thing is basically everything above the slab then is digitally designed and fabricated and with shop drawings and everything like that. So if you visited the site, you noticed the hoarding. That hoarding was actually my shop drawings. I figured I might as well just put them on display so people can understand the thing. So, you know, it introduced the project, but it also showed all the main components of the whole house. This is beyond the raft slab and the SIP panel basement. We use Simpson panels to create a moment frame on the cheap. So these things are way simpler to use than a big steel frame. Thermally, it's way better as well. Big glulam beams on the top, connecting everything together. NLT floor for the basement suite because it has an intrinsic fire rating. LVL floor, although the manufacturer calls it mass plywood, for the office level to make as thin a floor as we possibly could have. So that floor is only 4 inches thick. That means that the basement doesn't have to go very far on the ground. So this is the LVL being put on place. And glulam beam just on the edge, also very, very skinny. So then I ended up actually doing the shop drawings for it because the manufacturer was just getting up and running and they didn't really have that capability yet. Probably the last time I want to do that, but it's possible. And it's a nice product. So houses need internal walls? No, they don't. Clear spanning structural systems exist. Might as well use them. In this case, it was DLT, so dowel laminated timber, another fairly new product to the Vancouver market. Longer history in Europe. And then that used a little bit of steel perpendicular to the span to go in with a couple inches more concrete to make it a hybrid structural system to allow 2x8s to span 26 feet. It's a long way to have only 2x8 span. It was a bit wobbly and bouncy before the concrete went on, but as soon as the concrete was there, then it was bomber and like, it was really impressive. So this is from StructureCraft. And I counted it, there's actually 6 different flavors of mass timber. On this, the thing that I'm not missing was a couple headers or PSLs. But it's interesting because the Simpson panels are essentially just big OSB. And all of these things were used basically for significant structural reasons. It might seem weird to have this many, but each type of mass timber has its things that it's good at. So this house is basically tuned to use the things that it's all good at. Regular SIP panels for the rest of the shell. Mostly 12 inches thick, some 9 inches to allow the mechanical chase on the east wall. And then big glulam beams spanning side to side about 24 feet. The pink coating is actually a fluid applied WRB, which was the substrate for the EFIS skin that went on later. And I thought, well, as long as we've got one layer on anyway, the manufacturer had pre-applied stuff before for use in schools. And this gave the house a nice umbrella because, you know, it does rain here in Vancouver. So why not, because these things are OSB and you know, it's a bit of a risk, let's ameliorate most of that risk by pre-coating them. This is why I wanted to use the shop drawings that were in 3D and not have to tell the SIP company in 2D how to do it. I didn't want to have to figure out all these angles, and because I just give them the 3D model, I didn't have to. It's great. So the whole thing then could go together pretty quickly. And then as soon as the SIP panels went up, then they could have their seams all taped. And essentially for a little while, it was a cathedral inside. Anyone who did the Passive House social in this space, I really wish I had like videotaped a cellist or something like that. It was pretty cool. Of course, you know, walls came into this space later, so it lost a little bit of that coolness. But still, it made for a tremendously simple envelope system too, because it was just one SIP panel line the entire way down to the basement, 4 inches of external insulation everywhere. So it just became really easy to line up all the different layers. There's a couple through-wall flashings in between. And this makes it really easy to do a really good air test when you've got fluid applied WRBs, really good sealing, really big panels. You've got no place for air to go. So in this case, a preliminary test was actually 0.15, which is, you know, not so bad. Caveat is that it was done before the big windows were put in. I don't have the data for the more recent ones. So this was the shell and the upper windows only, and then poly off for the rest. So the poly will perform better, so the house will perform a bit worse, but that's going to be the ballpark. I was interested to see this window detail at BCIT. So this is a local school that teaches Passive House people in Vancouver, and using this interesting fiberglass angle, and that's exactly what we did for ours. So the north windows are sitting on the fiberglass. It's thermally about the same as wood, so it makes it really easy to hang a big window on something that has very little thermal bridge. To help that out a little bit, we did use a little bit of heating. If it had been a floor covering on this floor, we could have used like a in-floor wire. In this case, we'd have the mass timber only, so we had to do something that could be applied on the surface. So this was something used more for like roofs, for doing heat tracing of gutters, but it works perfectly indoors as well. So big windows, of course, require big cranes. These windows are 8 by 9 feet, so, you know, not that big. The ones on the south side are bigger. As I mentioned, those ones are the ones measured in Stevens. So it's an EFIS coating on both levels, tool to look like concrete on the lower level and just pure white up top. And then all the gutters are actually running sort of externally, sort of internally. So it's outside of the WRB, inside of the EFIS coating. So if there was ever a leak in here, you don't really have to care too much because it's easy to address if there was. So it's basically the least risky way of doing a internal gutter, and that's pretty and architectural and makes me happy that you can possibly do. So we use these copper boxes that were custom made to go through a little custom parapet cap. And the pipes just go through 2 of them so that it can fit within the 4-inch EFIS layer. And then you can see how all the structure just perfectly lines up. You've got a little bit of external insulation with some through-wall flashings, otherwise everything just sticks on top of each other. It's the simplest thing in the world. So with some actually very nice tooling on the EFIS to make the concrete pattern. So I was really impressed with these folks. I'd use them again. Outside of the house at that point was mostly finished looking. Inside was like this. So the inside lagged the outside. And here you can see the DLT, the LVL, and a few of the other things. The LVL we actually used for some of the walls and also the stairs and a bunch of other things. Because I thought might as well treat it like furniture as well. You know, use furniture out of plywood, so let's just scale it up about 10 times and make it out. Mass timber means toilets are a bit tricky, so we actually had to do wall-mounted toilets so we could have the pipes run through the wall everywhere. That was the main annoyance, really. Everything else wasn't all that tricky with it. So there's fern cavity everywhere. Initially, this was going to have insulation in it. We were able to eliminate all that insulation because of the really good air test. So, you know, about $20,000 of rock salt went out the window, which was useful. So this was just for drywall and that's it, and for services, and made it a lot easier to do everything. So you can see all the tape joints on the panels outside and inside. Living room, then we propped up the floor to camber the floor a little bit, so when we poured the concrete, it then settled flat. And then this became an interesting, so the interior and exterior you can see with the, where the roof deck is. Normally the situation would rely either quite a big step down or quite a big step up to get enough insulation. Whereas I did this instead. So this is using a skinny SIP panel and then vacuum insulation above it. Vacuum insulation in this case, it's just sitting there with gravity. So it's the easiest way you could possibly use it. This was some like overstock stuff from Panasonic, which is actually really cheap. Even at cost, even at like normal cost, it's only about $8 or $10 a square foot though. So it's really not that bad compared to its insulated value and how much benefit you can have in this situation. It does require a lot of care when you're putting it in. So the, everyone on site didn't let the roofers do it. Contractor did it. Quickly did it when before the roofer was going to do it. Put the insulation, put the board on top to protect it, and then the roofers put the roof on the next day. Mechanical systems ended up being a little small. I think there's some swears were set at me. You can see both sand tanks at the bottom of the shaft there. HRVs were on top. It worked. I planned it out ahead of time to know that it could work. It was just tight. So, but in a house in Vancouver, real estate's at a premium, so you can't not have tight things, basically. Here's the living room before we started doing any furnishing, any layers, so you can see all the guts. Some of the nice mass timber. So these were essentially just offcuts from that floor that we got to use then everywhere else. So all the stair treads are chunks of mass timber. Ends up, being nice that you can have this stuff featured then really nicely. So the final living room then, the lights ended up being a little bit heavy. That was the interior designer's decision. But otherwise, it makes a pretty good room. So it's 25 feet wide by about 35 feet deep. It's about as big a room as you could possibly make on this lot in this city. So, it's a pretty good space. Basement suite has exposed NLT ceiling on half of it. So that's using the specific fire rules that allow one depth to have one fire rating and a smaller depth with drywall also to have the same fire rating. In the office, the ceiling gets the very similar look, but this time out of DLT. And it went DLT instead of NLT because we literally couldn't get 2x8s long enough to clear a span without going to Alabama and ordering a train car full. The EFIS ended up being tooled really, really nicely. I was impressed with these guys' work. They really embraced really clean architectural details. And of course, because of that parapet and internal gutter detail, I didn't really have to have overhangs while still having good factor of safety with my envelope system. And then here's the house basically done. This was a couple days ago. You can see the gutter on the roof basically starts at 0 when it's on the ridge and then drops down to about 8 inches deep when it's on the corners. Because of course you don't need a gutter when you don't have any roof slope to feed into it. So that's why it pitches up proportionally with the roof drop. Good also cutting the carbon footprint down when you're doing all your site reviews on a bike. And then using some Akoya to keep it exposed for the front entry porch. So the whole house went from this to this. And I have absolutely no idea where I am for time, but that was it. I think I went through the slides a little faster than I thought.
Wow. If anybody wants to unmute and do a round of applause, I think it's totally appropriate.
Wow.
Absolutely.
Yay!
That was great. Really great.
I just you have more different technologies and components and approaches in one relatively compact house than some large buildings do. And I just love the way it kind of serves as a skunkworks for so many of those. Sean, are you on deck and online to help us queue up some questions? Is that literally crickets I'm hearing when I ask that question?
No, sorry. Again, we're working on multiple devices on a crappy Wi-Fi. Peter from Oshawa, you were up first. Then we have Atlanta and then Jeffrey. Get ready, everybody.
Hello,
Peter,
good.
you there?
Yes, there we are. Hit the unmute button, very small. Yeah, just asking what choice was made for the exterior, like the finished roof surface for the butterfly roof, and what did you use for valleys?
The valleys have a flashing underneath the membrane. The roof pit beams actually diverge a little bit, so it gets a natural slope to the valley.
Good choice.
And so it gets a 2% slope. And then the surface itself was, I forget if it ended up being PVC or I think it ended up being PVC.
Okay. You wouldn't choose a mod bitumen like from Suprema?
I was really wanting to actually use a perfect white fluid applied like the Ulsan actually, but
yeah,
cost was too high. We couldn't find anyone to apply it. That was not going to charge way too much. So that was going to be first choice. We ended up going with something a bit cheaper.
Okay. What about standing seam metal? Would that do?
The other thing we wanted to do was actually do a solar panel. So
excellent.
There's some solar tiles from Germany which are diamond shaped.
Yes.
Which match the geometry of the house really well. So wanted something that was not that expensive as a substrate for a future decision also, to not like go quite as much money as a metal seam would be. So there's a couple decisions over top of each other.
As my decade in roofing of all kinds, shingle, wood, metal, shake, this is, thanks. You know, I like to see what you're using, and solar panels should be the future finished roof surface everywhere.
I agree.
So
they're a little costly right now still. I mean, really not that bad. It would have been like 35 grand's worth, and it was just a little bit more than they wanted to do right now. It would be easy to do later. There's a wire run for it as well, so it could happen at any time later.
Yeah, it should be like click and play, just the same way that metal shake roofing is attached and connected, and then one runs into the other if it's sloped. Good design, thank you. Very nice house.
Thank you.
Okay, Alana, you had a couple questions.
Yeah, first question, you mentioned at the beginning earthquake resilience. I was curious about how all these systems kind of work together for that. And the second question was just in terms of, you know, I've come across some questions over the years about durability of vacuum insulated panels. Wanted to know if you've learned anything about that, or if you know, obviously you put them in, but I was curious about that part as well.
For the earthquake resilience, so I asked the engineers basically to, instead of going to the code minimum standard for seismic, it's actually designed so it's sort of post-disaster rated, so that the structure itself shouldn't have any damage, as opposed to most houses that they'll have damage but they won't fall down. So basically everything's just beefed up a little bit.
So that's kind of the sizing of your SIPs and all of that, or your?
I'm sorry?
It's the sizing of your sort of structure, you know, like your SIPs and your?
More just all the lateral bracing. So the SIPs are doing vertical work only. So it's the lateral bracing that's doing it. So on the corners, there's double up Simpson panels side back to back, just to add a little bit more than they could do by themselves, for instance. And essentially the house becomes a 3-story house instead of a 2-story because of the use of the SIP panel for the basement. So it's not, you know, outside of the realm of, you know, very normal systems anyway. It just happens to have some dirt around one of the stories. For the vacuum insulation, that's why we've got 2 layers of it on top of each other, and with staggered joints, so that we never have, you know, if one goes, you know, it doesn't matter too much. 2, we've got a SIP panel that's still 6 inches worth of SIP panel underneath it. So, you know, we've got a fail safe. Even if everything went, it's still pretty good. These panels do have an air absorber in them as well. So they should test out for a pretty long time. So that's why it's multiple levels of kind of foolproofness. And it's using the most durable bagging that they make, basically, these panels did. So yes, it's not proven out in buildings that much. Kind of proven out in other things, and like every fridge now has them, and they seem to work pretty well. So it's not like that we don't know that they're going to last at least a decade or 2. We just don't know after that. And then, but there's a lot of things that we put on buildings you don't know after 20 years.
Of course.
You don't worry too much.
Great questions. We've got Caleb. Sorry, Jeff. I'll just bump Caleb in because I forgot about him. Caleb, are you there?
Yeah, I didn't really ask a question other than how wide the house was.
It's a good question, especially when, Ian had to
somebody
deal with all these
answered.
crazy designs.
Yeah, somebody answered though 26 feet, which
Well,
I guess
26-foot span, the actual house is wider. It's a 40-foot lot. It's got 5-yard side yards. So basically the whole house is 30 feet
30
wide.
feet. That's pretty much the limit of the mass timber. And then why the concrete pour on top?
It's called a hybrid structural system because the concrete's working in compression, the wood's working in tension, and otherwise you just have to upsize your wood quite a bit to get the same stiffness out of it.
Is there some kind of nails for bonding? And
there's basically 2 and a bit inch by 1/4 inch steel strips cut into the wood half their depth and running perpendicular to the span at 6 different locations across the floor. So they basically key the 2 things together so they can't move. And because it's a DLT, it's only a one-way span anyway. So these are just running perpendicular to that span. If it was a CLT and you wanted to do it, you'd have to do something that bonded 2 ways. You'd have to use screws or some other product to bond in all direction. But this was just a one-way span, so it could just have the strips. And it's pretty easy just to saw with a kerf blade and cut a slot at a slight angle.
were those kerfed on site, or you had them done in the factory?
They just did it on site to be able to align them better. Just big straight edge and a saw, and just cut a slot into it. These DLT you can get either with big panels that require complex shop drawings, or they basically crank out a more industrial version that's about 2 feet wide that you basically just order width, depth, length, and it's just like a shopping list. So these were basically not adjusted at all by StructureCraft. These were all done on site, whereas the LVL was all cut by the factory, basically.
That's like that's a new one on me. So thank you very much. That's a cool new system.
Yes, Ian just did so many cool things on this. Every time you go back, he's like, "Oh yeah, by the way, I did this and did that," and you're just like mind blown every time you're on the job site.
Way too much, maybe. Yeah.
And Mike also just commented too about the concrete helps out with sound as well. Did you have to? Did you also determine the thickness to deal with sound, or?
On a NLT assembly, you need 4 inches to get a STC rating of 50. So that's what we've done on the living room floor to separate it from the basement suite. And it's more of a function that there's very few tested assemblies for NLT/DLT. There's a lot more for CLT. And there's a lot fewer sound paths as well through CLT because you've got the crossing. There's no kind of through paths. So those are a little bit better, but it would be nice if there was some more testing so that we didn't have to use that concrete there. We could have used the gypsum product, for instance. The hybrid floor is 3 inches, so it's a similar ballpark, but it's within one housing unit. So, and we also had carpeted floor above, so I wasn't too concerned about it. It was going to be pretty close to the same range.
Gotcha. Okay, because I can't type, we've got Jeffrey, Dan, and Dorothy. So Jeffrey, do you want to come on?
Sure. It's just amazing. It looks like it's a NASA level of technology there. And I guess my question was more around, or was all around, you and the structural engineer and the relationship. I mean, you had to have a structural engineer par extraordinaire, both in terms of his ability to know this stuff and take risks. So could you talk about that relationship and who brought the ideas and how you work together?
So this was Aspect Structural Engineering. And Aspect formed, it was younger guys from a couple of the wood specialty firms around Vancouver who all gang together as like a super team. They want to do, cool things. And I used them on a previous project. And I knew that they really liked collaborating on a project. Not just sort of simply, yes, I'll engineer your thing, but actually offering things back. And I had done enough chatting with them. I knew the capabilities in general, what mass timber could do. So basically the design was done in mind of ballpark of what I knew it should be able to theoretically do. General commercial spans up to 30 feet. We were in that general ballpark. So I knew vaguely that these things could happen. And then I knew that they were going to be able to play a really willing participant in this kind of stuff, and that they were flexible enough in their mindset and not worried about kind of doing some of their own research. So I really enjoyed working with them, and and happy to do so in the future. Yeah, some engineers, yeah, no, you'd throw this thing at them and they would say no.
I would say probably maybe 98 point plus engineers would have a heart attack trying to do some of these things.
Yes.
When did you bring them into the process? Were they like right there at the start?
Pretty much, yeah.
Okay.
Which I think for Passive House you kind of have to do anyway. Like I wouldn't want to go down the road on any of these things. And the Passive Houses I have on now, structural is in, right? Everything is in right now as well. You know, early, just because otherwise you discover weird things later. And it does take an engineer who's used to doing that as well. Unfortunately, I'm not using Aspect on one project right now, and it's harder because I'm sort of having to lead them, and it's not a place that they're happy to be, and neither am I, but it needs to go that place, so I'm forcing them. So, you know, you have to know your stuff to be able to push back too.
All right, great stuff, Dan. Now we have Dorothy up next, and then Mark and Bronwyn in the queue. Dorothy?
I was just curious, because you have so many different systems in a way, like with all the different types of wood and all of the things that you're putting in there, it's very, like you're saying, kind of, you were working really with these people. I'm just wondering, what was your project budget? How did that come out cost per square footage compared to like other things that are being built in Vancouver at this time?
Average cost of like a custom house in Vancouver right now is well north of $400 per square foot. This isn't that high. So it punches below its weight in terms of cost, and it punches above its weight in terms of what it's doing. I mean, a lot of the finishes in Chai were specifically chosen for being like architecty cool rather than being expensive. So, you know, that certainly helps out, and because you can change a project's budget massively by not having a built up kind of kitchen and spending 150 grand there, for instance. So I was always planning this around essentially like IKEA level of cabinetry with nice skins, you know, used in a cool fashion, not necessarily a luxury fashion. So that definitely, I mean, that had a massive factor because, yeah, the shell and everything else was more costly. I think the plumber was suggesting he was probably about 20% higher than he would have otherwise been just from the futzing. And that was probably true for a couple of, you know, in terms of labor, at least for the trades. The materials themselves don't necessarily change. So, you know, that washes out to a good bit as well.
And
yeah, all my numbers are Canadian, by the way, so yeah.
And Scott and Alan had the same question, and just so everyone knows, in this part of Westside Vancouver, prices per square foot range from $350 to about $800. So it's pretty low in the neighborhood for what you're getting.
Ditto that.
Sorry, Mark.
So I'm a big fan of dowels. I happen to have one in my hand, and I loved your project visually. Visually alone, right? It pops out on the street, and then internally when you walked us through it, could you just elaborate more on how you got to that conclusion on the DLT and how the process was selected and accepted as well?
So the living room floor was site built NLT. And I'll get to the whole thing. So it was site built because it was weird shaped. Almost no one makes NLT anymore. And we knew we needed it because of its fire resistance. It was built into the Vancouver Code. Both TNG and NLT are baked in there from studies from like 1942. I've actually got, here we go. Here's the specific code. So as long as you've got 114 or 165 millimeters, you've got your rating. 114 needs a ½ inch of gypsum. The living room was going to be the living room ceiling was actually going to be site built as well. I was actually looking at doing the entire shell first and then filling it in with the floor later and treating it more like a tilt up. But it turned out the straw that broke the camel's back was basically engineering told us, oh yeah, those have to be long span single pieces of wood. Because although you can splice together an NLT floor, it means it's less stiff. And basically that would take it below the threshold. So then I was searching around, where can I get 26-foot long studs? Like, this is hard. And the only place I could find was southern yellow pine from Alabama, which would have been great wood. Keep it dry, of course, because otherwise it does weird things. But it would have taken a long time and everything like that. The other thing we could have used was finger jointed lumber, but no one in BC makes big enough that's structural rated stuff anymore, with all the mills basically have closed that did all the cool things in the past. So Structure Craft basically has their own finger jointer. They do that exactly, but for their own stuff. And so by using the 2-foot wide billets instead of the big panels, I was able to keep the cost in the relatively same ballpark as what the NLT would have ended up being. NLT would have ended up being about $18 a square foot, I think. I figured, if you assume labor rates, whatever. The DLT was about 22. The DLT, if it had been big panels, would have been like 30. And CLT would have been higher than that. And GLT, which is basically a glue lam, but in a panel form, would have been more like 40. So the delta between all these things is actually pretty huge. And also some of the local CLT places, they won't even deal with a small project. Like, they don't care. And Structure Craft, like, I know them enough that they were willing to do a fairly small job for me, and especially since I was okay with doing the 2-foot wide billets. I curved the edge a little bit so you can't really see the gap in between the panels so much, because there's a gap between each board, so you don't notice the slightly bigger gap between each panel. In the end, they had time that they would have been able to do the big ones as well, but it wasn't necessary, and it was just easier to do the 2-foot ones instead. It's a simpler solution. There's becoming more mass timber available, but I think, like, for the LVL, we were literally the first architectural project I think that used it, because at that point they didn't even have their structural certification in the States to use it. Whereas in Canada, you're allowed the structural engineer can sign off on it, and then you can use it. So structural engineer, they were flexible. Like I said before, they got all the testing data. They were fine with it. So, like, yeah, sure, let's use it. So there was some flexibility there than to use things that we otherwise wouldn't.
So if you haven't realized it, the ability that Ian has done to research his projects is insane. And we could have conversations of things he's researched that he's planning on his next projects that will blow your mind. So we'll come back to that, because I know people want to talk more about the prices in the after hour. So moving along, Bronwyn, you're up next, and then we have Tom Phillips and Nick.
Thanks, Sean. Ian, fantastic project. And I want to ask specifically about your window detail, because I noticed you've got a really nice little drip weep at the header, and I wanted to know what have you put there, because that's always a detail that I never see done properly, and I'd love to see your profile there. It looks fantastic.
Let me see if I can. I don't have a drawing that shows it all that well that I've got open. So basically, it's the 4-inch. Here, share screen. So it's the 4-inch ephes layer. So they just kept the bottom open. The surface out here is tapered downward, so that it'll drain outward. This one is also tapered slightly downward so that water won't, by capillary action, go towards the window. The flashing on side is thick enough that it reaches to the edge of where the kickback foam is, and then it seals up against the opening. And so these openings are also sealed with a fluid applied WRP, which is a vapor closed one on the sills and sides, as a comparison against the vapor open one, which is used everywhere else. So it's then it was all one. So this is 8x for the stucco system, for the entire ephes system, and some guys called Charles Joseph Plastering, who were super interested in doing good details and making everything nice and clean in a way that not many people do, but can do.
Fantastic. Those are beautiful. I'd love to see the drawing section, if you don't mind sharing it sometime. Post it on your Twitter account.
Sure.
Thanks, Ian.
Great stuff. Moving along, Tom Phillips.
Oh, hi. Yeah, beautiful project. I wouldn't mind living there, I guess. The roof lacks overhangs, and that always raises a red flag when I remember the wind-driven rain problems in Canada, and where they recommend overhangs. And so, and maybe that's not a problem with all your ceiling and recessed windows. And then the other question, as usual, is about overheating analysis, because I couldn't tell how much southern or eastern western exposure you have that's not shaded.
Eastern and western is very, very low. Here are the percentages of percentage of windows in east and west is small. And they're all sunk basically all the way through the facade. So they're lined up with the inside of the SIP panel. So they're, it's more than a foot. So they're pretty well shaded. And since they're small, it doesn't really become much of an issue. It's the north and south ones that were the driving for all of it. So that's why we had to overdo our envelope pretty much everywhere a little bit to make up, especially for the north window being, quite large.
It looked like you had a retractable awning in one picture, but I couldn't really tell.
Yep. I can go back here.
Are those the south windows, the big ones?
Those are the north ones. Oh. So this is so you enter basically the office floor, which is the first floor, is basically right at head level. You drop down a couple steps. And then in Vancouver, you can have a light well and you can have a porch. I don't think they intend that you can combine these things together, but I did. And so that's why we were allowed one big, huge light well essentially for the entire front facade. Because otherwise you'd have to, you wouldn't be able to do this much of a change of grade. Balcony, where was that photo? Sorry if you get,
it was early on, yeah.
Oh, yeah.
No worries, Ian. It's always good to see these slides again. They were fantastic.
Do you have a wind-driven rain problem? Oh, there it is. Nice.
Yeah, so those go out 3 meters. We were thinking of doing ones that a little bit more even, because this protects the windows. It's still not quite enough to protect the actual entire deck from sun, but these things get costly as they go, get too big. You can see we've got some hats on the windows on the second floor, and there's actually going to be a shading frame up here as well, connecting the peak roof, which is going to have wires coming down to make like a virtual wall. So that will be.
Is that a little deck up there on top?
Yeah. So that's for the kids have their own roof deck basically.
Oh, great.
And then the entire planter wall is, the entire parapet wall is also planter. So you can have stuff growing up it. I'm suggesting hops, but I don't know if that's my advice or not. In terms of wind-driven rain, yes, it's an issue. But that's why, I've got, you do have a bit of an overhang with, but have the good WRB, which doesn't mind seeing some moisture. And then have big overhangs for all the windows. So yeah, this becomes the architecture versus perfect envelope, and in this case the architecture wins a little bit, but I think I've put enough fail-safes in that it's pretty well protected.
Yeah, Ian, and again, you're very creative in making sure this works. And if for those that didn't quite understand where the roof has the panels, it's at this juncture. So just in case if anyone was confused of that awesome detail. Nick, you're up next.
Hi. You mentioned early on when you were talking about the basement, minimizing the use of concrete and then just doing a thin layer on the other floors, and then using a lot of wood products. So I was wondering if that was aimed at reducing embodied carbon in the building, and whether or not you guys did an analysis at the end of everything based on the carbon footprint for the building overall.
A bit. So yeah, I've done well actually on the site sign. This was my kind of very napkin math calculation, just using something from the Canadian Wood Council for generically how much wood there was in the project, how much that sequesters, blah, blah, blah. In very ballpark terms, basically the wood in the project balances out all the concrete.
Okay.
That's much worse math than I think, it really deserves. I did a little bit more on the savings on these basement SIPs versus doing this is math more for a slightly generic house than this one specifically.
Okay.
But if you swapped out, sort of a normal house's worth of concrete for these things, you'd have 6,800 kilograms of carbon for regular basement and 2,000 for this one.
Okay.
So, it's a 4,800 kilogram reduction, which is, enough to drive a Prius 45,000 kilometers equivalent. So it's not too bad. And yeah, I mean, the client didn't really have a carbon reduction thing. I do. So the basement SIPs also ended up not really being that much different in cost than if you add up all the labor and all the other thing for a concrete basement and also the delay that it causes.
Oh, interesting.
It was only a couple grand delta, so it was like, yeah, let's, these are good. These are interesting. Let's try them out.
Cool.
So I'm actually going to use them on a project in Cranbrook as well, because it's a short building season. We want to get the whole house. It's a big house and we want to get it done within one season.
Yeah.
Or at least closed in and out and, not have issues with that. So instead of spending a month of your year, just getting your basement done, let's do it in 3 days.
Yeah, that's awesome. Great project.
All right. Thanks, Nick. Zach, over to you.
Okay, great. Thank you. I just want to let everyone know we have a great presentation coming up next Wednesday. It's going to feature a historic passive house retrofit that River Architects did that became their architectural studio. So you can see it's a pretty cool building there, and we'll get all the details next Wednesday. So please join us.
And Monty?
Awesome. Well, thank you so much, Ian. It's an amazing, amazing house. I know we're all kind of stunned and our brains are going about, could we pull off a foundation without concrete? So thank you so much for that. Thanks, Zach. Great to see everybody. We're going to roll into the after hour here shortly. So stick around if you can, and if you need to leave, we hope to see you back here next week, same time, same station.